Hello and welcome to the second lecture of rules of replacement. In this lecture, what we are planning to do is to take very simple questions to just have a brief understanding of how to apply rules of replacement. Now, first thing before we start with the questions, most of the questions will be using both rules of replacement as well as rule of inference. Usually, whenever you will find a question, also you will see that they will call it the a very popular way of calling the rules of inference and rules of replacement is that use 19 rules to solve a question, right? So we will always be using both the rules of replacement as well as the rules of inference. If you remember, there are 10 rules of replacement in our book and 9 rules of inference in our book. So we make it as 19 rules. So most of the questions will be having both rules of inference and rules of replacement, and we will be using them as and when it is required. Now let us take few simple questions, right? So these simple questions will help us to have some groundwork, or I will say some basic I will say practice for doing them, because what I'm planning to do is that I will keep or prepare around 4 to 5 lectures on question solving, because we will be requiring a lot of questions to be solved, so that we understand the nitty-gritties of solving questions. Also, we will understand the types in which a question can come and how these questions need to be solved. So right, today or this lecture will be of very simple questions. Then we will have some say half difficult and half easy questions, something like that, of that middle level, and then slowly and slowly we will go to the higher or more difficult type of questions, more complex type of questions. So in your book also you will find mostly the initial questions are simpler and the later questions are a little bit difficult. So let us take the first question from your book only. The first question says negation of A, therefore A implies B. Now this is just a one-step question, but sometimes people get confused that how from negation of A I can create A implies B. So the step is very simple. If you put negation of A wedge B, so I have added on 1, so this is the addition which has been taking place, and then in the third step I can write it as A implies B, because I am using material implication over here. So you can see that the question is solved. Now it is important for us also to understand that sometimes, and this is what we will be doing in the later part of the course, in the later part of this say problem solving, that we need to solve the RHS a little bit. Like suppose if this was a very simple question, therefore you are not getting the idea. But whenever you find a question and you do not know how to go for it or how to solve it, so what we should do is that you should solve the RHS a little bit so that you understand that from where you will get this, right? Like suppose if I would have solved the, like this is the rough work which I am doing. So a rough work will be like if I write negation of A wedge B, because I know that if I will use material implication I will get this. So then you will get the idea that you already have this part in the question, right? And all you need to do is to add B and you will get the answer. So this is a trick which you may require in a lot of questions, most of the questions in fact, where you can solve the RHS a little bit and see what and how the premises can be transformed into, so that you get the desired result. We will talk about it more in the coming questions. So let us take more questions from your book. There is a question like this is also the same type of question, like 1 C, therefore D implies C. Now again, as I told you that if we solve the RHS a little bit, so you will see that it is D wedge C, right? Because if I use material implication over here, this is rough work. I am doing some rough work here. So this D wedge C, you get negation of D wedge C as after solving this one step. So you know that C is there. All you need to do is to add negation of D and then change the position. That means with the help of commutation. So how you will do it? You will write C wedge negation D. So this is one addition. Forget about this part. This is rough. Okay. Then you change the position, negation of D wedge C. So it is second commutation. Fine. And fourth, you will write it as D implies C. So this is third material implication, right? So this is how you can change the or get the answer, right? So this is also very simple question, 1-2 steps question, right? But as I told you before as well, you also need to do simple questions. I know that it is very important for all of us to do difficult questions so that we are more or well versed with the understanding. But simple questions, moderate questions, as well as difficult question, all of them needs to be solved in order to have a better grasp. Because sometimes you solve a lot of difficult questions, then you do not understand some simplicities which will be required below. And you may falter or you may get stuck in between even a simple question, right? So those things, the practice should be on each and every level so that you are very good at problem solving. Okay, now let us take the next question, which will be also a very simple question, but let us see if it is simple for you. The question says E implies F implies G. Okay, E implies F implies G. Therefore, F implies E implies G. Okay, now this is the question which has been given to us. Now again, if you remember, you cannot change the position of these two things, right? Because you can see that here the position has been changed. But you cannot use you cannot change the position of these things by using commutation. So if you use commutation on implication, it is not applicable. Yeah? And moreover, you cannot apply commutation on these two things because they are not in the single bracket. They are on different brackets as well. Yeah? Here and here if you see. So given that understanding, it is not going to be such a simple question. But still, it is a simple question. Let us again solve the RHS a little bit. We solve RHS to see that what can be the case. So if we apply negation, because we are applying material implication, we will say wedge, and then again we can apply material implication, so it will be negation E, wedge G, right? So we can break it and see this. Okay. Now you will have a little bit of idea, because if I solve this, I will get negation of E wedge, negation of F wedge G. If I apply, and I put this as rough work, this is rough. So please do not get confused that this is the part of the solution. This is the part of the solution. Okay, this is something which I am doing in my mind. You can always solve it in the rough place so that you have an idea that how to go for this question. So I applied material implication. I applied material implication on this step. Material implication will help you to turn an implication into a wedge function. So I have done this. Now, as you can see that the position of F should go here and the position of E should go here. And this is possible that E should go here and F should go here with the help of commutation. But right now, since they are in two different brackets, so what we will need to do is that we will have to use association. Negation of E wedge negation of F. First write like this, wedge G. So you used association in step number 2. Now you can use commutation. So you will use negation of F wedge negation of E wedge G. So this will be third commutation. Now again you need to change the bracket. So you write negation of F wedge, negation of E wedge G. This is fourth association. So you change the position of the bracket, and after that if you apply material implication, so it will be F implies E implies G. So it will be fifth material implication. Now, as you can see on this step as well as on this step or on this step, I have applied material equivalence at two places, right? I have applied material equivalence, material implication here as well as material implication here. You can apply the rule of, say, rule of replacement more than once in the same line. In fact, you can use, in a later stage, you will see that we will be using 2 or 3 rules in a single step as well. But then we will be writing the justification. One thing which I forgot telling you in the rule of inference and the rule of replacement case is that the rules of inference, they can only be used on whole lines. That means if suppose P implies Q dot R is there and P is there, you cannot come out with Q because you are applying the modus ponens rule here, which is not possible. If this R is not there, then only you can use this rule. But if this R is here, you cannot use the rule. That means that rules of inference can be applied on only whole lines. Rules of replacement are also used on whole lines. But rules of replacement can also be used on part of the line. Like suppose if I have P implies Q dot R. So, and I need to just apply here some rule. So I can write it as negation of Q implies negation of P dot R. I have not used the whole line. I have not touched this part. I have kept this part like this. I only applied the rule of replacement on the part of the line. So another important distinction between the rules of inference and the rules of replacement is that rules of inference can be applied only on whole lines of a proof. On the other hand, when we use rules of replacement, they can definitely be used on the whole line of the proof as well as on the part of the line. So rules of replacement can be used also on the part of the line, a small part of the line, whereas the rules of inference can be used only on the whole lines. You cannot find a part of the line and apply rules of inference over there. Okay, so this is another thing, and that comes from the understanding of equivalences, because equivalences can be, you can move from top to bottom, bottom to say the top, right, or from above below and so on. You can go from right to left, left to right with the equivalences. That those are rules of replacement. But when it comes to rules of inference, you will not get that chance, right? So that is something which you should remember, which you should understand as well. Anyways, let us do the next question, because we will be doing 2 or 3 questions more in this lecture, so that we have some basic idea of how to go for questions or how to solve these questions. Let us take another question. We can take a question like this: Q wedge R implies S. This is the first line. Therefore, Q implies S. So this is the question which has been given to us, that we need to solve. Q wedge R implies S, and from there we should get Q implies S, right? Now you can see that there is R here which we need to eliminate. Now for elimination, you can write it down as well. Usually we will be using some kind of distribution and then some kind of simplification. Usually this happens that you need to leave one part, right? So how to eliminate something is a very important thing for us. Similarly, how to add something, how to get something from somewhere, you need to add something and then put it over there, right? So these are few steps. The more we will solve questions, the more you will understand how it is done. Now, solving the RHS will not serve much of the purpose, because you know that it is negation of Q wedge S. So Q implies S or negation of Q wedge S will not give you much of insight into how to solve this question. Then how to solve this question? You need to understand that you have to eliminate the part R in this question, right? So this is something which you should remember. Let us try to first see what we can do here. Once we will do something here, then you will slowly and slowly gather that how this is coming out. Let us see, then I will tell you a few more things. I take it like this, that I will use material implication on this step. So it will become negation of, because suppose if it is P and it is Q, P implies Q. So it is going to be negation of P wedge Q. So this whole is negation of P. So I write it as here, and this will become S, right? Fine. Now what I should do, this is okay. First step, I have used material implication. Third, now I can see that there is a negation outside here. So we can use De Morgan's law. So I will apply De Morgan's law, negation of Q dot negation of R wedge S. So this is going to be on to De Morgan's law. Fine. Okay. Now what to do? Now what to do? Let me tell you the truth. Now you can do distribution. Huh? But as I have seen, students find it very difficult to apply distribution this way, that something is there and then wedge something, or if this is like something with the wedge here and dot something, there also you can apply distribution. People find it a little bit difficult from this side to this side, movement of this side to this side, because usually there are certain things which people find it easier and there are certain things which people find it difficult. Like most of the people on this earth are right-handed people, right? But does not matter. You can be a left-handed person as well. You can find it easier to use the left foot. You can find it easy to use the left hand. But this is a usual thing that most of the people on this earth are right-handed. So usually you will find across cultures and across civilizations that this right-handed people and right-handed understanding is more preferred, right? So similarly, I have seen in most of the students it is difficult for them to apply distribution from this side, like here, because we also say how to use distribution. P wedge Q dot R, we say it is equivalent to P wedge Q dot P wedge R, right? So we use it. We never say Q dot R wedge P is equivalent to, right? We also do not say it like that. So, but it is equivalent. In fact, this answer and this answer will be the same. So what you do, because if you find it difficult, if you do not find it difficult, there is absolutely no problem. But if you find it difficult, do one step more. If you do more steps, there is no problem. You write S wedge, negation of Q dot negation of R. Because if it is P wedge Q, so you can write it as Q wedge P. So what you have done, you have put on 3 commutation, right? You have applied on step number 3 commutation. Okay, now it is easier. So what we will do, we will make it as S wedge negation Q dot S wedge negation R, right? Now once we do this, what we will get, what we have done, this is on 4th we have applied distribution, right? Now we have applied distribution and we get this. Now if you see, we need to reject the R part. So I will leave this part and simplify this part only. S wedge negation Q. So it is on 5th simplification. Fine. I can also simplify this part, but this is not a requirement. If the answer would have been something else, I would have done that, and I will come to that part a little bit later. Now, as you can see that I got this. So you know that the answer requirement is Q implies S. So you can bring this Q here and S here. So you will write it as negation Q wedge S. So it will be 6th commutation. Fine. And then on 8th step, you can write it simply as Q implies S, because it is 7th material implication. Fine. So your question is done, it is solved, you got the answer which was required. Now there are a couple of things which I will like to tell you here, and that is going to be very important for you whenever you are solving questions. If you would have applied distribution here or here directly, then you do not need this commutation here. right? Because this will give you the answer negation of q wedge s dot negation of r wedge s, and then you can leave this part, and then this question will be 2 steps simpler, 2 steps shorter. But it depends whether it becomes simple for you or not, because simplicity, the definition of simplicity also change with the person, right? I can find something simple, something will be found by somebody else difficult. I can find something damn difficult, the rest of the world is doing it simply, right? So those things happen. But the question is not that, the question is about where you find convenient. So this could have been solved in 6 steps, but I'm doing 8 steps, does not matter. If you take more steps and still solve it, it's fine. If you take less steps and still solve it, it's fine. But there is one important thing more which you need to remember. Suppose if the question would have been R implies S, because if this question would have come that okay, prove R implies S. So in place of negation of Q implies S, which was given to you, if the requirement was R implies S. So what you should have done, you should have commuted. You should have got this negation S wedge negation R first, simplify here S wedge negation R, this thing, and you would have left this as eliminate this, and after that if you would have solved, you would have got R implies S. So these smaller things are certain things which you should remember for any kind of question solving. So I will keep it simple till here, because these were some simple questions which I wanted you to solve and which I wanted you to practice. There are more questions both in Copy as well as in Harley, and I expect you people to solve those questions. Before I leave this class, allow me to tell you one more thing. You will not get anything here unless you remember the rules. So it is very important for all of you to remember the rules of inference as well as the rules of replacement. Till the time you do not remember them, you cannot see the solution coming out. Because in order to see the solution coming out, you need to remember the rules and then see that how this question can be transformed to the conclusion. Because you will get the premise, you will get the conclusion, but the solution will only come out when you remember the rules properly. So it is my request to remember the rules. Thank you.